So welcome back students. So in the previous class we had implemented this particular program. We have learned about what exactly variables are, and we also have just learned about the rules of defining a variable. There are something more about variables that I want to talk about today, and that is in Python we never declare a variable. Please understand this, that variable declaration is not done in Python. So if you have worked with some other programming languages like C, C++, or Java, so over there first you have to declare a variable and then you can use a variable. Okay, now this is a code that I'm showing you for C or C++. Suppose you want to declare a variable n. So I have to first declare it something like int and then give a space and a. Okay, now what exactly this means is that I have declared a variable, the name of the variable is a, and I have specified the data type of a variable. Now this is a new term for you, a data type. What exactly a data type is? A data type means the type of data the variable is going to hold. Okay, so if you want I can type this for you, like the type of data a variable is going to hold, which means the type of data variable is going to hold. For example, suppose if I declare a variable that is int a, and why I'm showing this code to you that is of C or C++ is because I want to make you understand the difference between the other programming languages and the programming language like Python. Okay, so over here comes the declaration for C or C++, that int a. So it says, a is a variable of type int, which means integer. Okay, integer. So a is a variable of type integer variable. So a is an integer variable. So once it is an integer variable, so I can only give integer numbers, or I can only store integer numbers in a variable. Okay, that's the first thing. So I cannot store any other data type in that particular variable, that is a. So I say, for example, a is equal to, and over here if I say that is a is equal to 2, so that's completely fine. But if I do something like this, like a is equal to 2.2, now 2.2 is like a decimal values, that is a decimal point we have. So such numbers are called as floating numbers, okay, which has a fractional value. So floating numbers, so this is a floating number and not a integer number. So what is that exactly is an integer number? As you might be aware of, that integer number is number that is a whole number, so there is no decimal point into it, right? Just like 2 or maybe 25, 45, so these are like whole numbers. But if I give something like 45.5, so this becomes a floating number. So floating numbers, if this is an integer variable, so if I say a is a variable of type int, so this can only store can only store integer variables, and it cannot store floating numbers. So if I give something like a is equal to 2.2, then if it is a C or C++, so or Java, so it is going to give me an error. Okay, so we need to declare the variable, and in the declaration we declare, I mean, which type of variable it is going to be. So I said that a is a variable of type integer, so it is only going to store integer number. So if I try to give something else, it is going to give you an error. The compiler for C or C++ or Java is going to throw an error. But now comes with Python. In Python it does not happen. In Python what we do is, the very important point that I'm going to type over here is that Python is a dynamic language. Okay, so these are all very new terms for you. So Python is a dynamic language. Okay, please remember this. Now this is a term, something that you're going to understand slowly. Okay, once we start programming, and then you kind of, after a few months, you can say that slowly you're going to understand what dynamic language is. At this point, I'm going to try my level best to make you understand that dynamic language means, everything is done during runtime. Even that is a point. So dynamic dynamic means, um, or you can say dynamic means, like runtime, or there's more than sufficient means runtime. So like variables. So uh, example, uh, like defining variables, assigning values, or assigning values, different values. Okay, you can remove this if you want, like defining variables. Okay, so dynamic means like things happen during the runtime, and runtime things will change. Okay, so over here, what we are doing is, this is a C or C++ code, you can take this as, and this is a Python code. So a is equal to 2. Now what I'm doing is, we do not have any declaration in Python, because Python is a dynamic language, and languages like C or C++, so I've typed this also, C or C++, are static languages. Okay, static languages. So these are static languages, and Python is a dynamic language. So if we say static, which means during the compile time or during the designing time, we have to tell everything to the compiler that a is going to be a variable which is going to be of integer type, and it will only store integer numbers. Okay, but in Python it does not happen. So Python, everything is dynamic. So if I say a is equal to 2, so during the runtime what happens is, interpreter is going to take this as, okay, a has the value 2, which means a is going to be a integer variable. Now this is happening during the runtime and not during the design time. This is a bit complex. Maybe at this point it is, maybe it won't be that clear to you, but as I said, slowly when you start programming, you will slowly understand this. So when I say a is equal to 2 out here, so when the interpreter is going to interpret this, so it is going to take a as a variable. It has the value what, 2. Now 2 is an integer number, so it is going to consider a as integer. Okay, next if I say a is equal to 2.2, now it's the same variable. Okay, same variable, and Python is no error. There won't be any error for this. But if you talk about other languages which are static language, there will be an error, but over here there won't be any error. So if I say a is equal to 2.2, now what happens is, Python is going to interpret, okay, now a has the value 2.2, which is a floating number, which means a is a floating variable. So Python is going to change the data type dynamically. So this is happening dynamically, and so Python is a dynamic language. This is a concept that should be very much clear to you. And if I say a is equal to, maybe sunbeam, now I've given a string value. This is a string. String means a set of characters. So these are like set of characters. So I've just given a double quote which makes this as a constant, and I've given that value to a. So a has the value that is sunbeam. So now again the Python interpreter says, okay, now a has the value which is a string value, which means a is a string variable. So depending on what kind of data you're assigning to a variable, Python is going to take that variable of that particular data type. So if you assign a is equal to 2, it is going to consider a as integer. If you give the value 2.2, it is going to take this as a floating variable. If you give a string, so it is going to take that as a string variable. And this is happening dynamically. When the program is actually running, these changes are taking place, and so Python is a dynamic language. And I can simply go ahead and print the value of a out here. Okay, and so there is no error. I will remove this time, and simply I will give over here again, I print the same value, and the same I can do it over here, print a, and it's going to skip. And I've just removed this for a few moments, and now if I run this particular code, you can see absolutely there is no error. So it is saying a is equal to 2 at this point. Okay, Python has taken the variable a as integer variable. Over here it changed, the data type got changed, so it considered a as a floating number. Over here, okay, we gave sunbeam and then we printed, so now it has taken a as a string variable. So depending on the type of data you are assigning to the variable, it is going to assume that particular variable of that particular data type. And this is the reason why Python is a dynamic language. If you work with other programming languages, other static languages like C, C++ or Java, then you will understand the difference. Maybe you can easily understand the difference. Okay, but still I've shown you the code. This is a C++ code, you can say, and this is how we need to declare a variable, define, declare which kind of data type it is going to be, and then only that particular data type we can assign to the variable. But since Python is a dynamic language, you can change the data type, understand it. Okay, so that was the first thing, children. And the second thing that I want to tell you is, um, how the variable, normal variables like these variables or integer, now integer, floating, and variables, or even string variables or character variables. Strings is but let us talk about integer and floating variables. Okay, these are like variables are immutable variables. Okay, immutable. Now this is another new word for you. Okay, so immutable means that immutable means the value cannot be changed. Now this is very confusing again, because now we are assigning the value 2 over here, then we are printing it, then we are giving the we are assigning the value 2.2, which means I have changed the value. So value is getting changed again. Over here I've changed the value is getting changed. So why we are saying that integer or floating variables are immutable variables? Now that is because what is happening. I'll just tell you with the help of a small design. So let us assume that this is the memory block. Now what is a memory block? We have learned about RAM and ROM. Why do we require a RAM, children? We require a RAM for the program execution, right? I always remember this thing. We require a memory, and when we talk about memory, we are actually referring to the primary memory and not the secondary memory. So when we talk about memory, we are talking about the RAM. So every program runs through the RAM. This is what we have learned. So even this is a program, right? Even this is a small program. Even this is going to get loaded onto the RAM, and through the RAM it will going to get executed. So when I say that a is equal to 2, so somewhere this value 2 is going to get stored, and where it is going to get stored, all these are temporary data which gets stored in the RAM, and that is why we have RAM for the program execution, for storing the data, for a temporary purpose. That is the reason we have RAM. Okay, and for the fast execution, and right, fast execution, we require a RAM. So when I say a is equal to 2, it is going to get stored onto the RAM, and RAM has memory blocks, and these blocks have addresses. So if I say this is take this as maybe green, and then I will just copy paste this, and maybe I'll consider this as a memory block. So this is a memory block, and this will be the address of the block. So if I say, let me just have some number 1 or 2048, assume that this is the memory address of this particular block. This is the address of this block. Okay, and I have stored the number that is 2. I've stored the number that is 2. So 2 is stored in the memory block which has the address that is 2048. Let me just run this. Okay, 2048 is the memory block. Okay, the address, this is the address, and this is the value that is stored in the block. And what is the value? The value is 2, and this is the address of that block. Every memory blocks have address. Using that address only we can access the memory blocks. Okay. Now what is happening? I declared a variable that was a. So a will be simply pointing to that particular memory block which has the value 2. Okay, which has the value 2. Now what happens if I give, that is I give another value. I give an another value, and the value was what? That value as per our code is concerned, it was 2.2, right? I hope this is clear. Okay, 2.2 was the value. So even this has a memory block. So maybe I'll say this is 1, 0 and 4, 8. Okay, so that's the memory address and that's the block. So I gave the value that is 2.2, and again I change that value, and this will be a bigger block. It is a string, and so this is like sunbeam over here, and then there will be some address to this as well. So if it's 1 0, maybe 5 6 or whatever it is. Okay, so these are different addresses. So a is simply pointing to that value that is 2, and if I assign the value a different value that is 2.2, so it will not point to this, it is going to point to a memory new block that is 2.2. Again, if I change that value, give that as sunbeam, so it will not point to this, it will point to a new block which has the value that is sunbeam. So understand, this is how a variable, integer variables or floating variables or string variables, basically they work. Okay, so these are immutable variables, which means I'm not a simply pointing to this block. So this value 2, okay, will remain as it is. The block remains as it is. Okay, even 2.2 will remain as it is, and this will also remain as it is. So the value over here is not getting changed. 2 will remain as it is. Simply a will point to a new memory block. Okay, over here also it is going to point to a new memory block, and this is what is happening. Okay, now let us do one interesting thing. Now what I will do is I will discard this, and let us go to the Python code, and I will say that okay, I'll remove all this. Okay, and we will do something really interesting. I say b is equal to 2. Okay, b is equal to 2, and then I'm printing a again, sorry, b out here, and let us run this particular code, and output that we are going to have is 2 and 2. That's pretty simple. That's very simple to understand. It's simply printing the values. Now what happens over here, Python is does some smart memory management. What happens is, let me again run this, and okay, let me take the pen. Okay, what happens is, a we assign the value a, that is 2. So a will pointing to the memory block that is 2, which has the value 2, and this is the address. And then I have defined one more variable that is b, and what was the value that I gave to it? That was also 2. So what happens is, it's not like it is going to have a memory block and the value will be 2 and some address of that particular block. This is not going to happen. What is going to happen is, Python will simply make the variable that is b to point to the same memory block. So a is pointing to the same memory block, b will also point to the same memory block. Okay, and then I will also prove this by doing some coding. Okay, and suppose if I say a b is equal to 5, that's my next statement. In this case, b will be given a new block which has the value 5. But if two variables has the same value, both the variables will point to the same memory block. Okay, and let us prove this with the help of the code. How we are going to prove this is, there is a function, name of the function is id. So I will print id, which is going to display the memory address of a. What it is going to display? The memory address, id. If I say id, it is going to display the memory address. So I say id of b. So what I'm doing over here, I'll simply give the memory address is equal to, and comma, and same thing, or memory address of a is equal to, and the same thing I'm going to do it over here as well. So that is B, and let me just give a comma. So id, okay, now this is a new function id. It is going to print the address where A is pointing. Okay, fine. So I'm going to display the id of A and B, and let us see what exactly is the output. And you can see, children, this is the output. Can you see this number? A is pointing to this particular memory location, that is 8182915270 and over here you can see the id of B. Even B is also having the same number, which proves that A and B are pointing to the same memory block. Okay, now if I change this, if I just give the value like 5, and now if I run this particular code, children, you can see that A is having this memory block, whereas B is having some other memory block. Okay, children, so I hope this is clear to you now. This is a bit, a bit complicated to understand at this point, but you need to really work on this. This is something I'm going to give it to you. Okay, so I'll just select everything, and I'll go to the word, and I will paste it, and you can practice this, children, and this concept should be very much clear. So today we have learned some deeper things. Okay, what is the difference between a static language and a dynamic language, and how Python works with the variables, and how the memory is assigned, the memory blocks are assigned. So I'm going to paste over here, and let me just give the name to this as as I will call this as memory or variable or immutable variables. Okay, immutable underscore variables. So save it with this. Okay, I'm saving it in class 12. This is class 11, and I'll save it over here, and let me just generate the PDF. So I'll give this PDF to you. Okay, so there it is. We have generated the PDF as well. So that's it, children. So please practice this, and then we will meet again tomorrow. So today we have really learned something interesting about Python, and these are something, we do not find this in the book. Book will only tell you what the language is, what are the rules, what are the syntax, and what are the tools basically. Okay, but to learn a programming language, you need to really work with that programming language, then you can deeply understand it. Okay, so that's it for today. Bye for now.